Okay, so in this video, we're doing question number 20 from chapter 1. So this question is really getting at your understanding of descriptive and inferential statistics. So investment manager survey. So a survey of 131 investment managers in Barron's Big Money poll revealed the following. Okay, so before we read any further, let's figure out what's going on. So first of all, Barron's, this is like a magazine, newspaper. It's published by the Dow Jones. So basically what they did was they had some type of poll, a survey where they were researching people. So who were they researching? Who were they interested in surveying and learning more about? Right, a survey of 131 investment managers. So investment managers, that's clearly the population that they're interested in studying. All investment managers. The sample, however, is this 131 that they came across. So we have our population, all investment managers, and we have our sample, these 131 investment managers that they surveyed. So let's keep going. So here's some of the findings that they have from this survey. 43% of managers classified themselves as bullish or very bullish on the stock market. The average expected return over the next 12 months for equities was 11.2%. 21% selected healthcare as the sector most likely to lead the market in the next 12 months. When asked to estimate how long it would take for tech and telecom stocks to resume sustainable growth, the manager's average response was 2.5 years. Okay, so cite two descriptive statistics. So again, descriptive statistics just describe the data. So technically, these are all descriptive statistics. They're describing the data that was collected on these investment managers. So 43% of managers classified themselves as bullish or very bullish on the stock market, right? That's a descriptive statistic. So almost half think that they're bullish or very bullish. So these are descriptive statistics. They're also sampling statistics because they're statistics based off of the sample. So we're covering that material. And then B and C, make an inference about the population, right, population of all investment managers concerning the average return expected on equities over the next 12 months. Right, so this question is really getting at your understanding of inferential statistics. So remember from the video and from the textbook, inferential statistics is basically when you take your sample and you get a sample statistic, right, you can use that as an estimate of the population parameter, right, and that is called inferential statistics. So basically that's what we can do. We can take these sampling statistics and use them as estimates of our population. So this one is looking at the average expected return over the next 12 months, right? So that's basically what the inference would be. We could say that the average expected return over the next 12 months for all investment managers, right, the population, is estimated to be 11.2%, right? And that's right here, right? So all we're doing is we're taking our sample and our sampling statistic and making the inference about the population, right? All investment managers. And right, remember that's why we do statistics, inferential statistics, is because it's not feasible to survey all investment managers. Instead, we just take a sample and we use that sample to represent and to get estimates of our population. So this seems like, okay, that's it, that's statistics. But when we talk about probability in part 2 of this course, we're going to talk about understanding sampling distributions, and how that's related to probability, so that when we get to part 3, we can build on that. And what we'll start to do is we'll add more information to our sampling statistics. What we'll do is we'll say that, we can be about 95% confident that the actual population parameter is within this range. So we're going to add to this, but for right now, it's basically it's important just to understand these basic principles that we have about inferential statistics and how they're related to samples, populations, sampling statistics, and population parameters.